So in part one of this video, we're going to take a look at a HeathKit H8 I recently acquired at a Hamfest. We'll take a peek inside, check out the boards, do a gross test of the DC voltages from the power supply, and maybe take a peek and see if it powers up. So I thought today we'd start taking a look at this HeathKit H8 computer I acquired several months ago. I've done a little bit of preliminary teardown on it, just to understand how to get into the case, etc. I have worked through the assembly manual, so I have a fair understanding of how the system's put together mechanically, etc. One of the things I wanted to focus on first is this power supply checkout. So there's steps here to go through the gross deep DC power supply. So let's go ahead and pull the lid off and take a look at how it came delivered. Grab a screwdriver here. We'll need to do a bit of disassembly. So the system came with the 3 boards you see installed. There's the 8080 processor card up here on the front. So just a couple of quick notes. There's a brace that sits along back here to hold this side of the cards stationary. I've removed that brace. Anyhow, so the brace is off. There was 3 cards in the system. 8080 processor. There's a serial I/O card with a ribbon cable that goes off to a connector here on the back. I've got an H9 terminal that came with it, and the cable that goes, I believe, between this connector and the H9 terminal. As configured here, this is just a very basic system. It's got the original Heath monitor and ROM, as I understand it. So there's things I can do. Tilt this up. You can see it. There's things I can do from the little front panel here and the displays, and that's about all this configuration is capable of. Is pretty simple stuff. The serial I/O card actually has cassette input and output, it turns out here, so you could save and record programs. But the first thing I want to do is pull the cards out, get everything isolated from the bus, and then I want to check the gross DC power supplies. There's a large electrolytic capacitor underneath this backing plate here that is the main filter capacitor. It's just a large electrolytic, 77,000 microfarad, I believe. The supply produces, it's pretty much what you saw in S100 buses, something like plus and minus 15 to plus and minus 20, and then a 7 to I think 9 volt DC output, and then you end up with a local regulation. So if we pull the processor card out here, oh, I forgot, it's got cables that go off to other aspects of the system. Let's start with the serial card. We'll need to remove this ribbon cable. So these boards have a 5 volt regulator, 7805 here, on this little metal bracket to act as a heat sink. So it's picking up the gross power supply voltages from the pins on the input here. I believe pin 0 was ground, and then pin 1 is a power rail. I believe 48 and 49 are power rails. I don't remember exactly what voltages they are. I believe this cable goes off to the remote on a cassette recorder to start the motor, start it running or not. A couple of read relays here. Anyhow, we'll look at this card in a little more detail later. Let's pull it out and set it aside here. We have a memory card that is obviously not a HeathKit supplied card. This is quite an interesting card. What you may notice here is this is a S100 card. So it's a, I believe, 64K looking at this. These are 4116s. Spin it around here so it's upright. So they are 16K by 1 DRAM. So there's a bank of 16K, 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 and 16K. So there is 64K of installed memory on this card. 8080 being an 8-bit processor has a flat address space of 64K. So this card would potentially occupy the full memory map. of the processor, except of course there's a ROM on the CPU card with a monitor in it, stuff like that. So there's been something done here to disable this card, talking to some memory addresses. There's some buffer logic here on the back to get it onto and off of the bus, and a little bit of TTL, I'm assuming gating logic to control that gating. These connectors come to a series of wire wrap pins. Those wire wrap pins wrap around to this S100 connector here, and then there's just this S100 RAM card chugged in here. There's onboard regulation here for the memory, and there's onboard regulation here that appears to me like it runs underneath the card. It's hard to see, and I believe brings power over. Actually, it comes out over here. So this regulator, through this little gray cable there, drops through the proto board here and becomes the power supply for this bit of logic here. There's a tantalum cap there. So definitely not original equipment. I do have a couple of cards here that are original memory cards. I'm told at least one of them has a problem. We'll look at that. I'm told the last time this thing was powered up, it was operational. So I'm going to try to bring it up in the configuration that was delivered to me. We'll see. So anyhow, interesting card. I don't know that I've ever seen anything like this on the web. I'm pretty new to the H8 and I've done some research, but I haven't exhaustively searched the web. So I suspect this is a pretty unique adaptation here. These are dynamic RAMs. They're 4116s. Said 16K by 1. Dynamic. The 8080 does not produce the refresh signals required for DRAMs. So I'm assuming this logic here is producing the refresh signals to keep the DRAMs refresh. I guess I could look this up, expand RAM. That's about got to be the case. The original S100 machines started with the 8080 processor, and there was no refresh, and so you had to generate DRAM refresh some other way. There's enough logic here that this isn't just gating logic, to select banks. There's something more going on here. I'm guessing this little module here might be an oscillator of some kind. I don't know that. I don't see a crystal on here anyplace that could produce timing to drive the refresh circuit. So I'm pretty sure that's going to be some kind of an oscillator that ultimately drives refresh signals to refresh the DRAMs. So kind of a neat implementation. Somebody put a lot of work into this. The age is showing. The corrosion on these pins is horrendous. The corrosion on the wire wrap joints is horrendous. Although I'm going to assume the wrap joints are making good contact. When you wire wrap, the reason these pins are square is it gives them those sharp corners, and when you wire wrap and twist the wire on tight, that sharp corner bites a little bit into the actual raw wire and creates what's called a gas tight connection. The idea being that connection, because it's gas tight, won't corrode internally and will maintain a good positive electrical connection. Don't know that for sure at this point, but anyhow, there might be some challenges there. Let me loosen up a screw over here. If I can get the screwdriver into the slot. As always, I've got the wrong glasses on and I can't see the slot. Let's see if I've got a better pair for this laying around here. That's much better. Sorry if the bald spot in my head is getting into frame. So that releases this front cover with our little HeathKit badge, the piece of red plexiglass. Well, not plexiglass, just red plastic for the LEDs. There used to be a strip of foam up under here. That foam is completely died and is gone. I will look at some point at replacing that. I've removed the screws that hold this front panel in place, and I did that intentionally because ultimately I want to be able to isolate these connectors and get the card off, and that way I can simply look at the raw power rails on here to make sure that we don't have something way out of spec with the potential to damage something. Need to be careful here. This wiring isn't super fragile, but it's definitely not, mil spec. That should isolate the front panel at least that far. I don't know what this F and E lead are here. I can see them running all the way back to here. They appear to go into the power supply. Those are on breakaways, it looks like, so I will remove them. Construction here is quite interesting. There's another voltage regulator. Don't know if I've got this in shot. Let me slide the computer back a bit. There's another voltage regulator hidden up underneath right here on this metal bracket. It's labeled plus 5V minus. That's interesting. Okay, it's a little line. So plus 5 there, plus 8N, and ground, of course. There's another little, most likely 7805 there. There's another one hidden up under here. Voltage regulator again on this metal stiffening plate on the back. So that really is the local regulation. These are labeled F and E. Even though I've kind of been through the assembly manual, I've not looked at the construction manuals for these cards. So I can't say absolutely what those are. That ground, yep. You see that ground pin has come loose out of the connector and it's just floating there. That's not a particularly good thing. At least I'm assuming it's ground. Let me find the exacto if I can spot it here. And I'm going to take the little retaining pin and just flex it up slightly here. I'm sure you can't see this. There's a little pin that sticks up out of the connector. That pin engages in the slot here to hold the wire in place. And I'm just going to slide him in, hopefully. Or maybe not. Until he clicks into place. I didn't flex that much. That shouldn't be that stiff. Oh, great. That is soldered on, but it's a pretty not great solder joint. That should just slide. There it is. Yeah, no. I think I just slid it in incorrectly. I didn't get it on one of the little slots. That's not engaging. I don't want to flex that too much and break it. There, it caught. So this is labeled pin 1 to 5. This is labeled pin 1. So I'll be able to get that back on correctly. We can take a look at the 8080 processor here. So it's a date code of 36th week of, I believe, 78. Yeah, based on 36th week of 77. Do I see any other date codes that pop out? 47th week of 78. This is going to be the 36th week of 1978 for the 8080 processor. Of course, the system clock on here is going to be the, is it 2-phase, I think, for the 8080 clock generator. This has got to be the ROM for the monitor. It's a neck rounded part of 2308, I believe. Yeah, I believe that's an 8K mask programmable ROM, I believe. 74 LS438. I should know what that is, and it's not clicking offhand. I'm looking for a clock generator. There was a chip in the 8080 chipset that was the, I believe, the multi-phase clock generator. I could be wrong. don't remember offhand. Anyhow, I'm going to assume this is an operational card, and this is the other thing I noticed looking down inside is this dead bug style chip on the back here. It's kind of hard to say what it is. There's a number of pins on this side that are floating, which means they can oscillate. And in looking at the color of the wrap wire, trying to guess where pin 1 is on the device. I can see the notch over here. Wow, really? Trying to figure out where they're picking power and ground up here. And this might actually have the part number on the back. Or not. So kind of trying to figure out the wire that taps off. So okay, that looks like it must be VCC. There's a cap here that's going to this corner pin up here on this piece of 74 logic. So that's got to be +5. That's got to be the +5 rail. That drops through to here. There's a piece of red wire here that picks it up. So there's pin 14 on the device. So we've got power there, which means this blue lead is going to pick up ground from someplace. And man, that's really weird. That has to be ground. If that's VCC there and it's coming off there, opposite corner has to be ground, assuming it's just a kind of a standard TTL device. It's epoxied on, so I'm not going to try to remove it at the moment. You can see that wire flexing to here, going to there. That is certainly not a ground. That's truly confusing. I'm going to fire up the ohm meter here and just probe a little bit. Now, oops, let me get continuity mode. So we've determined that that is VCC, and that says that has to be VSS, and it's not. What have they done here? Maybe it's not a TTL device. I actually don't see a ground connection, which is extremely mystifying. There's ground there. Okay, the pin out of this is weird. Well, that pin is attached to ground. It doesn't mean it is ground. I don't know what that device is. The power pins on it are kind of weird. It's almost like VCC and ground are on pin 1 and pin 8, although they just maybe jumping a pin to ground. I would have to decode the edge connector here. I don't know if this has to do with the DRAM board. Anyhow, we'll set this board aside. Don't want to lay it there. And we're really down to this front panel card. And I'm going to see if I can release these, and I can. And that should completely isolate this card. And there's the front panel, 7-segment displays, little keyboard. We have the segment drivers here, 1, 2, 3, 4, 5, 6, 7, 8. So that's the segment drivers with decimal point based on what I saw in the schematic. Power input, there's a tantalum cap, there's 4 status LEDs here that have been banged around and are crooked, probably by me. On the nice side of this, everything is socketed. I'm seeing a little bit of what I call pin rot, and that is device pins turning black. That can keep you from running. This device right here, they're pretty dark. Actually, these 3. These look like they're probably single wipe sockets, which means reliability, they are single wipe sockets. So the sockets are only making contact on one side of the device pin rather than both. And that just leads to long-term reliability issues. Again, the idea with the chip lead into the sockets to get a gas-tight connection, a nice tight connection on the metal pin to the metal socket connector. And if you keep oxygen out, you don't corrode. If that's loose and you get oxygen in there, you get corrosion. And eventually the pin disconnects and you have all kinds of reliability issues. The pins on those displays are absolutely black. The system's definitely kind of showing its age. They didn't bother to clean the flux up when they assembled it. I'm guilty of the same thing, so I won't pass judgment. Anyhow, let me set this card aside. Ooh. Nearly spilled my cup of coffee. That would have been bad news, especially because it's on the same table as the boards I just removed. Which probably means it would be a good idea to get, of course, putting the coffee there doesn't help that much. It can just spill over here. Going to the power supply. Troubleshooter here. This has you do some basic continuity tests first, just for the circuitry. I'm going to assume the gross connections and everything back here are good. Through a power switch, must be that right there. I can see there's a couple of, you can't see them, slide switches in here. It's set to 120 volts and it's set to normal there, and I suspect that's going to say low. So this is just set to normal 120 volt line voltage in the US. If your line is running 110, you'd click that down to low. Just to give you a little better raw DC conversion there. One of the things they press hard on here is actually getting some insulation on some of the pins you're not going to test. So I actually need to find a little something to insulate with. Don't know if the diameter of this is big enough or not, but we'll give it a shot. See if I can remove a bit of the insulation off of these leads. The idea here was to take this power rail pin, it's right by the ground, and cover it up. Yeah, that wire diameter was too small, so the lead insulation is too small. Let me find a little something here that I can remove some insulation from. Larger gauge wire, or smaller gauge wire actually, well, larger. See if that'll slide over the pin. And it does, although there's a piece of actual wire left in there. So the idea in the book is to cover up the pins you're not going to test, so you can't accidentally short to them. And short across the raw power supply. So I'm going to cover up those pins. Get these little bits of wire off of here before they get into the system. Jump up and take a look at the camera, and we are on camera. Get the meter back to volts. Find the line cord. Just kind of got scrunched up back here. Now, I don't know if the power switch is on or off. I still don't know because there's no noise. What we're going to do here is I'm going to get on the ground and we'll take a peek at this pin up here. And that's not measuring well at all. That's measuring. That's a capacitor discharging. I'm just watching the voltage rail just slowly drop off. So from there to there, we have 10.53 volts. So going from, see, I think I'm on the wrong pages here. Nope. Touch the meter probe to pin 1 and 49. Should indicate between 9 and 12 volts. So that's 1 to 49. And I measure in 10.5. So we're solidly inside of the range here. We want to check the other two voltages. So what I'm going to do is move this piece of insulation up. And this is pin 48. Or 47, I mean. Pin 47. Okay, I think 49, 48, 47. Let's insulate that. And I don't really think I need to do this second one because it's just the raw bus there, but I will be overly cautious and isolate both sides of the pin I want to measure. Get on ground here. And we're measuring plus 19 volts. And that's 1 to 47 is plus 19 volts. So it's in the middle of the range. I'm really curious here. There's the 10 volts there. If there's actually two pins bringing out the 10 volts onto the bus, that would make sense because it's going to be a pretty high current bus. And there's 10 volts on pins 49 and 48. So the last pin we want to measure, this one's going to be a little trickier to get to. So I'm going to pick up ground, back off pin 1 on this connector. I'm going to get to pin 2 here. I'm not measuring anything. Okay, have we got a power supply pulling? Let me hit pin 1 and 2 here. Turn the meter probe to plug P1, pin 2. I'm not seeing the negative rail. You know, from pin 1 here, there's the plus 5. I'm going to cheat without the insulation. There's the plus 19. I should see minus 19. I should see a gross DC voltage here. Touch the meter to plug P1, pin 2. Should indicate between minus. That is going to potentially be a problem. I think the DRAMs require a minus rail. I know the UART drivers, the serial driver requires a minus rail. I don't think the 8080 does, but I could be wrong. So the question becomes, what is wrong here? Well, this is why you check the power supply rails first. Boy, I really do keep slipping. They're commenting to put insulation over the adjacent pins is a good comment. So let's go ahead and shut it off. Oh, that squeal's obnoxious. I'm going to go ahead and see if I can remove this connector, just because it's at the moment obnoxiously in the way. There it goes. I'm just going to pull him out of the way. There are 3 mounting screws here that we're going to break loose so we can get into, I think those mounted a speaker. And I, of course, can't tighten those back up now. Let's get this cable output port cover off. Now I do have the 110 volts still plugged in on this. Good or bad? So I need to be a little bit cautious, although all of that's taking place on the primary side of the transformer over here. It feels like, based on the screws I felt back here, that protective cover is mounted from the back. Now, I know some people will take the time to document where every screw comes from to put it back in the original position. This was, you know, I don't think this is a factory assembled unit. I mean, maybe it is, although the quality of the soldering is pretty unhappy. Ah! We just learned something. The orange and white cables are simply the speaker. So, I knew there was a speaker buried in here. It's interesting that it doesn't have a grill. That's okay. Just tack what I loosened up back down. I want to wipe some of that dust out of there. So we have that large electrolytic here that's going to be on the 5-volt rail. Well, the 8 to 9 volt is what this is filtering. It gets regulated down to 5. There's 2 large stud diodes there. So there's a bridge. Clean a little bit of the dust and dead spiders out of there. So there's 2 diodes here. So there's going to be a half-wave rectifier, perhaps. It's not a full bridge, which is interesting. I'd have to look at the power supply schematic. Well, it's a center tap, so the 9 volts, the 8 to 9 volts that drives the 5-volt regulators, is a center tapped transformer. So there's 3 leads. The one with the yellow is the center tap. That looks like it's going off to the positive connection, which is interesting, on the capacitor. And then the 2 what appear to be negative sides go into these 2 diodes, which creates ground. Okay, yeah, that works. And ground back to the filter cap. So we know this large cap here has power on it simply because we saw the gross DC over here on this side. You know, there's just not a way to remove that, so it's just going to be an annoyance. If we take the meter here, we'll go ahead and apply power again, and we get on ground, and plus I should see that same 9 volts right here. Okay, 10.5. Was that what it measured before? It was 10.5. Yeah, 10.5. So, you know, I don't know under load if that 10 volt rail will drop down with the 7805 regulator. You know, it's a 1 amp or 1.5 amp depending on the model, or even a half amp. The problem here is you take the 10 volts and you regulate it down to 5 and you're drawing an amp. that means there is 5 volts of drop across that regulator. The regulator is working by taking the difference between the regulated voltage you want and the incoming voltage, and that delta it has to dissipate as heat. So if we were pulling a full amp off a 7805 and we had 5 volts we had to dissipate, we would have what, 5 watts? Power equals E times I. So 5 volts times 1 amp would be 5 watts. It can get rather warm. You definitely will need a heat sink. You keep looking further into the system. I would definitely assume that these 2 electrolytics hidden back in here are the plus and minus 20 volt regulators. There's 4 diodes in here. I can see them here that produce or that regulate. Again, the green leads here look like they're going to be the plus and minus 20 approximately supply. I don't know what the rating on the transformer is. Those come into a diode bridge here. Actually, it looks like 2 half wave. Not for half wave or not, but and these 2 become the filter caps. They're 25 volt, 2200 microfarad, so you know they're rated okay. There's a 150 ohm resistor here. Not sure what that is, whether it's a bleeder resistor to maybe bleed this guy down. It probably is. Anyhow, we saw the positive rail, we didn't see the negative rail, which says to me culprit most likely is going to be a bad diode. It's possible that one of the windings in the transformer is open, although I seriously doubt that. That looks like a pretty robust transformer. So at this point, because we have a common ground reference, I'm just going to reference this lead directly to what is obviously ground. This metal bracket here is ground. We know that. Where did I throw the pointer at? We know that because we see the negative terminal off the big filter cap going to this just a plug here, or this connector that's onto the chassis. So we know that that's a ground reference. And all 3 of the power supplies are going to be referenced against that same ground. The other thing I can tell just by looking at this is the positive side of this capacitor is here near the diodes. That's going to be the plus 20. The negative side of this capacitor is towards the diode, so that should be the negative 20 connection there. We'll find out. I've applied power. I've confirmed power. Just curious if I see that 10 volts. I do see that 10 volts directly across this large power resistor, this 150 ohm resistor. So that is a bleeder resistor, which means when you turn the power off, it discharges this cap. It's always a good thing. That way, eventually when you pull the cards out, that cap could hold charge for a long time. And if you had a really low current draw because things weren't active, you could actually be pulling a card off with voltage still applied. So I'm predicting that'll be plus 20 there. Actually, that's minus 20. And that's plus 20. So what have I... Oh, I read the markings on the capacitors wrong. The plus symbol's pointing to the back. So with this being the negative lead here near these 2 diodes, that's actually going to be the negative 20, and it's minus 19.7 volts. And plus 19.7 volts. So there's actually good regulation there. So the question becomes, why on pin 2 am I not seeing that voltage rail? And I'm just not. That's really curious. Am I reading this wrong? We will pin 1 to 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 20. Actually, 1 to 24. I would expect to see that negative rail right there. that's not a good thing. I mean, it's good that the diode bridge seems to be working, and the filter cap. Touch the meter probe to plug P1 pin 2. Should be that pin. Oh, curious. 24, 23, 22, 21, 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 7, 6, 5, 4, 3, 2. Uh-huh. That's really interesting. You get back in camera here, although you probably won't be able to see this very well. I'm going to turn the power off. You can actually watch. So this big filter cap's discharging. It's down to 7 volts, 6.5, 6. So the power's being bled off through that resistor as heat. I don't want that sliding around. So the discovery I just made was this, and hopefully this is somewhat in frame. I was counting pin 1, pin 2, pin 3. So when I hit pin 2 here, I didn't see the negative power supply. When I went to what is logically pin 3, I saw the negative power rail. So I'm guessing these two are ground in the same way these two were the +9 or +10. So does it actually start at pin 0 on this silk screen? It starts at pin 0 on the silk screen. That's really interesting. I wouldn't have guessed that. Oh, it's a 50-pin bus. I know the Benton Harbor bus is 50-pin, and the top pin's labeled 49, so yes, that would have been pin 0. So we have all three of the gross power supplies are there. So that's a nice thing. I can certainly live with that. At 5 volts should be pretty much discharged by now. Yeah, it's down under like 150 millivolts. And with that in place, I'm somewhat confident to move ahead with applying power here, putting some of this back together, and see if we get a front panel display. So it's really going to be the CPU card. Let's start with it. I do know that this P2 CPU or P... That is, yeah, this is the CPU position. I think the CPU was a dedicated position. I'm going to walk him on there. I'm not going to secure him at this point. I'll just kind of let him float. We will take the front panel. Let me slide this back. Hopefully it'll be a little better in frame. We'll take the front panel. Reattach the speaker here. As it is a speaker, honestly the polarity of these shouldn't matter. But it was white bottom, I believe. Orange top. We get these back on in the right positions, and I will come back and visually double check this after everything's plugged in. That is certainly a bit fidgety, and I got it on a pin off. There it is. A bit fidgety as well. So I can see based on the pin header down here that he's on the right position. He's on. There's a gap here that's supposed to be here. Pin 1's labeled on here as we talked about earlier. Oh, got a fly buzzing my coffee. That makes me happy. Not. It looks to me like I'm safe floating this card in here. It can't fall all the way back. There's no traces out of the edges where I could short something. So I think the front panel card, the wiring is making this rather painful to do. Did the processor card go? my mind there was actually a silkscreen marking. I was looking online. It said CPU, but maybe not. And honestly, given the tightness of the wiring behind there, card lays, okay, that's back in where that card actually goes. Get him on the proper set of pins. That looks very wrong. Better glasses will help. And it is off the pin. I don't like how much the bus flexes as I do this, but oh, he just got my bald spot in camera. He's up tight. Front panels laying back in place. I would expect the monitor to not run. It's got to use RAM. There's no RAM currently. It's put together this way. I'm guessing the 7-segment displays are, well, looking at the design, they are multiplexed in software. With this point, powering this up, I would expect it to do nothing. I set that back in there safely. Kind of. I think I need to put the screws back in and get that reattached firmly here, so it's not bopping around, potentially shorting something. And this was these two screws. So I can get that to catch there, and catch here. And we can tighten those up. Safest just to get this panel back on. Like I say, it slides around, it's metallic. It could slide up against those bus pins. Short, who knows what out, take the processor out, take all kinds of things out. So, protective covers back in. We have verified we have the gross DC power. Slide the memory card in. That should be enough to have an operational system. Whether it is, and it is. We have an operational system. I know that for two reasons. Oh, that squealing is obnoxious. You heard the speaker beep, and if you can see the 7-segment displays here, you'll see it actually wake up and give us the 377000000. So we have an operational system, excuse me, in this configuration. So I'm going to go ahead and end this piece of the video here. We'll come back around in the next video and take a play with the front panel, talk about the split octal display, which is interesting. Key in a memory test and just kind of give this thing a play and start to exercise it. So anyhow, I'll wrap this up here and we'll talk soon. Bye.